number 8, problem number 1. A 800 kilogram man is carrying a scale inside the elevator. Try to understand different scenario and how the scale read his weight in kilogram when the elevator goes to 4 different scenarios. Number 1, when elevator goes through constant velocity, when elevator accelerating up, when elevator accelerating down, when someone cut the rope. The person is, as you see, 80 kilogram. We're going to find bunch of information on this problem. As we know that here the person will feel same and the scale will read 80 kilogram, and here person will feel heavier. The elevator will read more than his weight, so more than 80 kilogram. Here lighter, the less than 80 kilogram. Here weightless, here weightless. Okay, so let's get it started. So let's draw 4 different scenario. So scenario number 1, scenario number 2, scenario number 3, and scenario number 4. Scenario number 1, the person weight is 80 times 10, 800 Newton, and the person normal force is also 800 Newton, is because acceleration is 0 and net force is 0. So this is also 800 Newton. 800 Newton. This is person weight also 800 Newton, and this is person weight also 800 Newton. So person weight doesn't change, even though here the elevator is constant velocity, here the elevator is accelerating up, here is elevator accelerating down, here someone cut the rope, the weight of the person remain the same. Okay, so that's what we're going to do right here. So we're going to write 800 Newton, 800 Newton, and 800 Newton. So the person weight remained the same. Now we're going to see the normal force. Of course, the normal force would be different. This one normal force is 800 is because net force is 0. This one the normal force would be different. So we're going to calculate the normal force. Normal force is mg plus a. Why mg plus a? Is because it is accelerating upward. So m is 80, g is 10, 10, a is 2, so 12, 0. So normal force would be 960 Newton. Let's see over here, Fn is mg minus a, g minus a. So Fn would be 80, 10 minus 2 would be 8. So Fn would be 640 Newton. In this case, Fn would be 0. Fn would be 0 is because the elevator is on free fall due to someone cutting the rope. So now we're gonna update it. This one is 800. Normal force is 800. This one normal force is 960. This one is 640, and this one is normal force is 0. All right, excellent. Now we're gonna find total acceleration. Total acceleration over here is 0. Total acceleration over here is 0. Total acceleration over is z plus a. Z is 10, a is 2, so 12. Total acceleration over here is z minus a. Z is 10, a is 2, so is 8. And total acceleration over here is 10. Alright, 10 is because acceleration due to gravity. Instead of 9.8 we are using 10. So net force over here is 0. Net force over here is 960 minus 800 is 160, and negative 160. This one is negative 160. That's why the person feel lighter. And this one net force is 800 Newton. Net force is 800 Newton. Okay, now we're gonna find the apparent weight loss. So apparent weight loss would be 0. Okay, apparent weight loss, in this case apparent weight loss is 0. Apparent weight loss in kilogram 0. Apparent weight gain is 0. Apparent weight gain in kilogram is 0. So experience is same. Even makes sense. Apparent weight gain, yeah, apparent weight gain is 160 Newton. 160 Newton. Apparent weight gain in kilogram 16 kilogram. 16 kilogram. So experience heavier. This one apparent weight loss. Yep, apparent weight loss is 160 Newton. Apparent weight loss in kilogram 16 kilogram. Apparent weight gain, now it's not a, doesn't apply here. It doesn't apply over here. Lighter. Alright, the last one is the cut the rope. When someone cut the rope, apparent weight loss. Apparent weight loss is 800 Newton. Apparent weight loss in kilogram, 80 kilogram. Apparent weight gain, no, that doesn't apply. Experience, weightlessness. Alright, now we're going to do the next problem. So next problem is that we have an Atwood machine. Let's draw a pulley. So we have a pulley and two meshes suspended on the pulley, and mesh number 1 is blue, and that is how much? Mesh number 1 is 1000 kilograms. So this is counterweight. MCG is 1150 kilogram. Accelerating, this one is accelerating, this one is accelerating up, this one is accelerating down, this one is accelerating down. Let's make this part of the rope green, and let's make this part of the rope blue. And what we are trying to say, we are trying to find the acceleration, and green acceleration is going to be equal to the blue acceleration. So let's get it started. So first do the blue one first. The blue one, this is MCG and this is FT. So FT minus MCG is equal to MCA, and this one would be MEG FT. So FT minus MEG is equal to minus is equal to minus MEA. Minus is because this is accelerating down. So now we're going to put this equation underneath of this equation, and let's see what happens. So FT minus MEG is equal to minus MEA. Now we're going to change the sign, and then we're going to cancel this one. So G then ME minus MC is equal to AME plus MC. So acceleration is ME minus MC multiply Z ME plus MC. So acceleration is ME is 1150 minus 1000 times 10 divided by 1000 plus 1150. So acceleration is 0.68 meter per second square. So this is the homework. If you still don't understand it, please shoot me an email and or see me during the office hour. Thank you.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.